Hello everyone, welcome to my channel. So today I will be discussing on the work problems and solutions for the exercise 1.5. So this is based on the chapter 1 sets on NCERT mathematics class 11th. So on my previous video, we have already discussed about what are the different operations of sets and also about what are Venn diagrams. And on this exercise, we will learn about what are the how to take a complement of a set. We'll do work problems based on that, and also we will solve work problems based on De Morgan's law. So what is actually this complement of a set? I've already discussed. If you have any doubts about this, please have a look on my playlist on NCERT mathematics class 11th chapter 1 sets. I have a playlist in my channel. You can go over there and select the which exercise video you wanted to see. I have explained in detail. So but for the time period, I'm just explaining about what is a complement of a set. So if you have a universal set and inside that if you have a subset A, the A complement is a set of all elements which does not belongs to the subset A is called A complement. And what is this De Morgan's law? That is, the complement of the union of two sets is same as the intersection of their complements, and also the complement of the intersection of two sets is same as the union of their complements. Don't worry about all these things. We'll do all these problems and you will have a better understanding, and then you will get a great idea about all these. Okay, so let's directly go with our work problems. The first problem is, let u is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and a is equal to 1, 2, 3, 4, b is equal to 2, 4, 6, 8, and c is equal to 3, 4, 5, 6. Find a complement. Find a complement is what? Set of all elements which does not belongs to the subset A. So 2, 4, 6, 8 you can't include in that. So 1, 3, 4 you can't include, 5, again 6 you can't include, 7 and 9. Right. So these are the elements of, sorry, I have taken with the element subset with A. So A is 1, 2, 3, 4. So all the elements, the rest of the elements, what are they? 5, 6, 7, 8 and 9. B is 2, 4, 6, 8. So B's complement is what? 1, 3, 5, 7 and 9. What is again A union C, the whole complement? Wow, it's getting interesting, right? First you have to find A union C and then you have to take the complement. What is A union C? 1, 2, 3, 4, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 is A union B, right? 3, 4, 5, 6. This is what A union C. Now you have to find what is A union C, the whole complement. The rest of the elements, what are they? 7, 8 and 9. Again, what is A union B? A union B is what? 1, 2, 3, 4. 1, 2, 3, 4, 6, 8. So what are the rest of the elements left? 5, 7 and 9, right? So A union B, the whole complement is 5, 7 and 9. Again, A complement, the whole complement. This you have learned using the law of double complementation. What is that? A complement, the whole complement is what? The same set A itself. So you can simply write it as set of 1, 2, 3, 4. So these are the elements of the set A. Again, what is B minus C, the whole complement? What is that? All the elements of set B, and these elements these elements are not the element of C. Only the elements which are from the set B. 2, 4, 6, 8, and in that you can see that 6 is a common for both B and C. So you have to avoid that, and the rest of the elements are called the elements of B minus 6. What are they? 2, 4 and 8. So that is B minus C. But for the question it is asked what? B minus C, the whole complement. So all the other numbers other than B minus 2, 4 and 8. What are they? 1, 3, 4, 5, 6, 7 and 9. I hope this problem is clear. Now let's do the second problem. If U is equal to A, B, C, D, E, F, G, H, find the complement of the following sets. It's again easy. Same as we have done for union and intersections. These are very easy problems. A is equal to A, B, C. So you have to find the A complement. What is that? Just write all the elements other than A, B and C. That is D, E, F, G, H. Again for B, D, E, F, G is there. So what is B complement again? What is that? A is there, then what? B is there, then C is there and H is there. So that is what B complement. Again, what is C complement? All the other numbers. What are these numbers? B is there, then D is there, F is there and H is there. Again, for D complement, what are the elements? B is there, A is already there, so you can't take that. B, C, and D and E. So these are the elements of D complement. So that was again easy problem. Now let's do the third problem in it. Taking the set of all natural numbers, set of natural numbers as a universal set. So the universal set or the basic set is a set of all natural numbers. Write down the complement of the following sets. So x says that x is an even natural number. So all the even natural numbers means what will be the set? Complement of it will be what? It will be the set of all odd natural numbers. So if we are taking the universal set as a base, so here what would be set? X says that x is an odd natural number would be the complement of the even natural number. X says that x is an odd natural number. Next, x says that x is an odd natural number. What it would be? Complement would be what? X says that x is an even natural number. Again, x says that x is a positive multiple of 3. What are the multiples of 3? 3, 6, 9, 12. So all the other elements are the complement of it. So how can we write? X says that x belongs to the natural number set and x is not a multiple of 3. X is not equal to multiple of 3. You can write it anyway, right? I'm just writing in the shortest way. X is not a multiple of 3. I mean like x is not a multiple of 3. You are writing in terms of set builder form. You can also write in roster form also, okay? So it's your convenience. X says that x is a prime number. So what is the complement of that? X says that x is a positive composite number and x is equal to 1. Right? X is a positive composite number and I say x is a positive composite number and x is equal to 1. So here you can say that x says that x is a prime number, it is said, right? So all other numbers which are not the prime numbers, that is x that x is a positive composite number. So this is the answer for the fourth problem. And now let's discuss the fifth part in it. So x says that x is a natural number and divisible by 3 and 5. So what would be the answer for that? X says that x is a natural number and it is not divisible by 3 and 5 will be the answer for that. X says that x is a natural number that is not divisible by 3 and 5. I hope it's clear for you guys too. Next, x says that x is a perfect square. So what you can write? X says that x belongs to n and x is not a perfect square. So all the other elements are the complement of that. X says that x is a perfect. Again, what you would write for x says that x is a perfect cube? The same way, you can write in the same way. X says that x belongs to n. X is not a perfect cube. Then x says that x plus 5 is equal to 8. So you can easily find the actually what is the value of x? 3. So all other numbers, x says that x belongs to n where x does not belongs to 3 is the answer for that. Because there is only one element in this set 3. Taking the complement it with a universal set, what it would be? All the elements other than the number 3. Again, x says that 2x plus 5 is equal to 9. So 2x is equal to 4 and x is equal to 2. So here same again what you can say that x says that x belongs to n and x does not belongs to 2. I'm not just elaborating it everything. I hope it's clear for you guys too. Again, x says that x is greater than or equal to 7. So what is the complement of that? All other numbers which are less than 7, right? X says that x belongs to n and where x is less than 7. It's easy. Now, the last problem in it, x says that x belongs to n and 2x plus 1 greater than 10. So what it would be? 2x plus 1 greater than 10. So you have to find that. 2x plus 1, that is 2x greater than 9 and x is greater than 4 by 9 by 2, that is 9 by 2, that is 4.5. X is greater than 4.5 means until 4. So until 4 you can write. So what you can write that belongs to n and 2x plus 1 greater than the element. All the elements which are less than or equal to 4.5. So you can, what are the elements actually? You can present in roast. All the questions I wrote in set builder 4. For a change, I am writing this in roster form. Okay, 1 2 3 4 are the elements. Or also you can write that x as that x belongs to n and where x is less than or equal to 9 by 2, or you can write as x less than or equal to 4 also. This will also give you the same answer. Okay, because 9 by 2 is 4.5 and the natural number less than that is 4. Obviously 4.5 is not a natural numbers, right? So this is the answer for the problem number 3. Now let's discuss the fourth problem in this section. If u is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and a is equal to 2, 4, 6, 7, 2, 4, 6, 8 and b is equal to 2, 3, 5, 7, verify that a union b complement is equal to a complement intersection b complement. Have you seen this equation somewhere? This is the one of the equations of De Morgan's law. What is De Morgan's law? I'm repeating again. The complement of the union of two sets is same as the intersections of their complement. That is shown in this question. And the second part, A intersection B the whole complement is equal to A complement union B complement. What is that again? The complement of the intersection of two set is same as the union of their complements. So saying with that, now let's write the answer. A union B. What is A union B here? Taking the union is A union B is 2, 3, 4, 5, 6, 7 and 8 is A union B, right? Now taking the complement of it from the universal set, so what you will get, 1 is left over and 9 is left over. Okay, so this is what A union B the whole complement. Now let's see what is A complement. A complement is what? 1 is there, 3 is there, 5 is there and 7 is there and 9 is there. What is B complement? 1, 2 is not there, 3 is not there, 4, then 6, 8 and 9. So what are the common elements in it? You can see only 1 and 1 and 9 and 9, right? Rest all there are no common elements. So A complement intersection B complement is again what? 1 and 9. And hence we have proved the first section of the problem. So it's the same. So hence we have proved also the De Morgan's law. Now let's do the second portion of it. A intersection B the whole complement. First of all, let's find what is A intersection B. What is A intersection B? A intersection B is 2. So what is A intersection B the whole complement? It is all the other elements other than 2. 1, 3, 4, 5, 6, 7, 8, 9. Now A complement is what? 1, 3, 5, 7 and 9. Again, what is B complement? 1, 4, 6, 8 and 9. Now take the union of both these sets, A complement union B complement, 1, 3, 4, 5, 6, 7, 8 and 9. Are these sets same? Yeah, they are equal. So hence again the second law of De Morgan's law is also verified using set example. So that's for the second problem. Now let's discuss the fifth problem in this question section. Draw appropriate Venn diagrams for each of these following. So wow, this is a very interesting question. Now you can draw something and you can, it's also a best for your thinking also. You will get a better understanding about this section. A union B the whole complement. How you will represent this? What is A union B? First of all, let's represent this as sets. A union B is this, all this. Complement of this what? The outer portion of A union B. That is A union B, the whole complement. Now which I have drawn in the shaded portion is the A union B in the figure. I hope this is clear. Now let's discuss the second portion. A complement intersection B complement. A complement intersection B complement is same as A union B the whole complement. It is same as the first problem itself. A complement intersection B complement. I know that directly so that I know that it's a portion outside the both A and B. So but for the exam, if you find anything difficulty, you can draw it separately also. It's also fine. See, for example, A complement is what? All the elements outside the set A. So this is the area. This is the set A, right? This is B. Now, what is B? B complement? All the elements outside the set B. So the set B means these are the A portion. And from these both sets, what are the common portion? The outside portion. And that's what I have marked here. Yeah. So that's all for the second part of the problem. Now let's discuss the third section, A intersection B the whole complement. All other parts other than the intersection. What are these parts? So A intersection B is a common portion for both A and B. Other than that portion, all other portion is the A intersection B, the whole complement. Again, A complement union B complement. Similarly, as the second section, you can find it, and you know that this is again the portion here A and B. So here all other portion other than the common portion for both A and B is the A complement union B complement. If you find it difficulty at the first Venn diagram itself is to draw, you can draw up to 2 to 3 or 3 to 4 Venn diagrams and represent each section by section. For example, in this problem, first you can draw what is A complement in it, then only B complement, then try to take the union. Union is about just taking the common or the all the elements of both the set. Intersection is about taking only the common elements of both the set. So by that you can rearrange the Venn diagrams and you can find the final answer. Only if you are sure enough about your answer, draw it within the first Venn diagram itself, or else you can take up to 2 or 3 Venn diagrams and take your time and draw the correct exact Venn diagram needed for the problem. Okay, so that's for the fifth problem. Now let's discuss the sixth problem in it. Let U be the set of all triangles in a plane. If A is a set of all triangles with at least one angle different from 60 degree, what is A complement? So you have now a universal set, and in that one set is there. Out of that, this set's prior characteristic is that one of the angles, the set of all triangles is at least one angle different from 60 degree. So what will be the triangles outside that? All the triangles with all the angles 60 degree. What are these triangles when all the angles are 60 degree? What is that? A complement's answer will be A complement will be the set of all equilateral triangles. So A complement here would be the set of all equilateral triangles. So this is the answer for the sixth problem. Now let's discuss the seventh section. Fill in the blanks to make each of the following a true statement. A union A complement. It's very easy. And what is it? It's a union set. That a set of all elements of A and the elements outside the set A. That is what the universal set. Again, phi complement. Phi complement is what? You have to remember the law of identity. If you take the complement of the empty set, what it would be? The universal set. So the universal set intersection A is what? A itself. That set itself. So that's the answer for that. And the next one, A complement intersection A intersection A complement. That is, if you take the common of both these, there are no elements which are in common. So it is an empty set. Again, union complement. What is union complement? Universal set complement. It is the empty set or the phi set. So phi set intersection A. If you take intersection with a empty set, you will always get a empty set of phi. So that's our answers for the problem number 1.5. And with this, we come to an end to this section. And on the next section, we will discuss about the work problems based on exercise 1.6. That are the practical work problems based on the chapter sets. And these problems we'll solve using the formulas of sets, using the union and intersection. So let's see you in my next video. Bye bye.